In real life, you may need transformations not just from JSON to relational, from relational to hierarchical JSON, but you may need data transformation from JSON to JSON. And whether or not this is part of a data pipeline between two different tables that you have, whether or not you're using a dynamic JSON, you already know how to do this by now. So I will focus here just on the actual queries that does this transformation from one JSON content to a different JSON content. So basically, we're talking about a different topology, yeah, hierarchical topology, because the data will still remain hierarchical, will still contain arrays and objects, yeah, dictionaries basically, but in a different topology. So I selected for you three different samples here. I will start with the first one, and I had to deal actually with this use case for a specific client. So keep in mind, this is something that may occur frequently in real life. So the client were receiving you see data in this format, properties, and then name, value, key value pairs. Yeah. So the keys were called name and value, and he was getting an object for each such pair of key names. Remember, key names. So uh, the name of the property was a value for the key name name, and the actual value was stored into a different under a different key called value. What's happening in real life? Yeah, you may need to do something like this. Definitely, just to strip out the name and the value as key names, and to apply directly the property name as a key name. Okay, so have a look here. We no longer have name and value as keys. We go directly to card ID, card number, and order ID as key names. And then on the right side, you have directly the values. So this is what we want to get, and this is our JSON data. Keep in mind that I save this as an SQL variable or a SQL session variable. You cannot do this even for test purposes, like here. You cannot do this if your data is over 256 bytes. Yeah, we're talking about a string data. So it is possible to do it here, and let's just run it one by one. Okay, and look, the way you can do it here. Yeah, let's have a look. I will parse this data because yes, I saved in the first column. Yeah, I saved in the first column that comes from values. Yeah, I will pass the string in the values. Remember, I cannot parse JSON directly in values, but I will do it this way. Yeah, we did this multiple times, no problem. I will parse this data and then I will flatten what? Have a look here, the properties. Yeah, the properties is an array here. Okay, that's an array. But look, the way I will convert this, the desired output is just one embedded object, is one embedded object with all these as properties. So I no longer have an array of objects. I have one nested object with all these as key value properties, basically. Yeah. Okay, so the way we can do it is this way. You get the value here, and yeah, we can address this as you can see here with a square bracket notation. Let's execute this one. Okay, so we got the key value pairs. Going further, yeah, for a fixed number of properties, what can we do right now? Yeah, we'll construct a top object, yeah, as you've seen before, with the properties keys. And here, object construct keep null because we have a name order ID with a null value. So we have to do this. You cannot if you call object construct order ID will be stripped out. So we don't want this. And here, look, this is hard coding, and this is for a fixed number of properties. Yeah, definitely that's not the best solution. Yeah, but we'll select name 0, 1, and 2. And what are these? If you look here, I will select from our JSON content what to character. Okay, I will separate name 0, 1, and 2 from the three objects in my array. Okay, If I run this, okay, have a look at this one. Yeah, I get to what expected. But that's not a generic solution, and definitely it's not good to assume that you'll have a fixed number of properties, just three here. And look, you'll call again and again the same functions basically to format each of these. So not the best solution, but just because we're experimenting, this could be your first step. For a variable number of properties, what we can do here is look from values. Okay, lateral flatten. Yeah, I will do this here. Let's see. Okay, I flatten the properties. Yeah, as before. But let's see. Okay, I will look for the name and the value. But look here, guys. Look here. So you remember we separated already in tabular format name and value. What you can do is to call object construct, but here on the right side to call object aggregate, yeah, with a name and the value keys. Okay, so this will basically each time build an object, yeah, for everything in this case, because we have no group by or whatever, yeah. For everything, this will collect one single top JSON object with the name and the value, the given name and the value. Let's execute this one and look. We get also what we want, but remember, this is generic. Yeah, this is not just for the three properties that we had here. Okay, let's move further. What we want here, look, I already saved inside an employees. We have basically, let's see, we have an employees underscore JSON table that I created before from this content. If it's not there, you already know, yeah, how to create this one. Create a single table with, yeah, called employees underscore JSON with a V variant, and just upload. You see this specific data here. What's particular for this data is highly hierarchical. Highly hierarchical. So you don't know the depth of this hierarchy here, because under each employee, starting with the president of the company, you get an array of employees which contains other employees, immediate subordinates. You see further here, Nina Gonchar. So this reports to the president, to Stephen King, but Nina Gonchar has her own direct subordinates and so on. Yeah, at some point you see Nancy Greenberg has her own employees and so on. So it's a very hierarchical structure. Sometimes it's very hard to handle. And what I want to do here is to move from this specific structure, look, to this structure. What I have here, yeah, on the first, I have an array of objects, yeah, and for each object, I have a manager property and I have a subordinates property, which is an array. I will keep just the names of the employees here. And for the manager, you get in the subordinates the immediate subordinates and so on. You can see here Nina Gonchar, but Nina Gonchar also appears below with other subordinates here. Okay, so going back here, how can we do this? And the challenge here will be to do this with plain SQL in Snowflake. Don't use any procedural language. Don't use user-defined functions and so on. Let's just do it in a plain SQL using all we know by now. Yeah, all the functions, the built-in functions, all the flatten, all the ways flatten works and so on. Let's do this in Snowflake. Okay, so first of all, look, we'll have to isolate the names here, and we have to keep this manager subordinates pairs. Yeah, let's do this in a tabular format, and you already know by now that look, if you call flatten with recursive true for all the employees here, yes, you'll get all that hierarchy, flexible hierarchy expanded. Okay, but you don't want to keep everything from that. So how to do this? Well, you see, you can further. That's one possible solution, and believe me, I had to experiment myself with this to figure out how can we do this. It's not so obvious, yeah. I will take the expanded element from for all the expanded employers here. And I will flatten further. You see what I will flatten? The parent. This is a parent of the element here. Why is this? Because looking at this, I want here the name, yeah, the name as a subordinate. Okay. So this here, yeah, this here further flattened will give me the subordinate, and he will stay as the parent, as a manager. So if I execute this, yeah, let's do this. Yeah, but first of all, let's see. We had some context. Yeah, I already executed this before. Yeah, because otherwise this wouldn't work. Yeah, because I look for everything from this table. Okay, so you can see here already. Yeah? Let me expand this a bit. Okay, we get all the manager subordinate pairs here. All the manager subordinate pairs, yeah, will keep just the names, and yeah, the names are unique, okay, because otherwise, yeah, you get in a lot of trouble. This wouldn't work. But we can assume, we can rely on the fact that the names are unique and they can be used as primary keys eventually. Okay. What we can further do here, if you look at this one, let's execute. You see, I slightly modify this one because I want to get what here? Let's call it as link. Okay, let's call this as a link, and you'll see why. I will get a nice structure like this one. I will copy this one, yeah, basically, yeah. I will say Control C to copy it, and I will paste this online. Okay, guys, I already did this here. You can see I went to the GraphViz visual editor, yeah, the visual editor that we already played with, and if you paste the pairs that we generated before in this specific format, yeah, I just did double quotes because the names have special characters inside, they have spaces, and look, for the link, yeah, that's a link manager to subordinate, and this is a nice graph that you can generate automatically. You can see the hierarchy if you do it this way. Okay, back to our project. Look, let's have a look at this one. This is a final query that I generated. And look, inside here, I just have the pairs. Yeah, just like before. Yeah, exactly. That's the initial query that I generated here. Yeah, no big deal. But now, from this manager subordinate pair, yeah, in tabular format, what I can do is, first of all, I will generate an object construct manager, and for the subordinates, I will get an array aggregation. Yeah, array aggregation, and you can see here partition by manager. Yeah, that's I'll use this as a window function, and grouped by basically by the manager. So I will collect all the subordinates for each manager here into an object, and then finally, yeah, remember this template because you may have to use it again and again. Yeah. So here we get several rows. Yes, basically you'll get this if you execute it. You'll get individual objects, one per row. What we want at the end is a final array. We want a final array with all these objects, and this is very simple, guys. That's why I use here two different CTEs, because the final query would be array aggregation of everything as an output from what I generated before. So array aggregation will basically collect everything from all the rows I have into one single top array. Let's run this. And yep, you can see here at the right, on the right side, I have an array, one single array with all the generated objects, yeah, each with a manager and with subordinates. Finally, I will get to something similar. I will start with the same employees JSON. Yeah, remember this hierarchy here. With this hierarchy, but right now I want the data in a different format. I want the data in this format. This is a format we use for a specific kind of visualization. If I remember correctly, this was a D3 network, yeah, network visualization. There was a one very animated and so on. So never mind, data is expected in this format. So basically, you have uh, each employee is given with all his or her previous direct manager. So you can see here, for instance, Shelly Higgins reports to Nina Gonchar, who reports to Stephen King, and so on. This is what you have here. You have one entry for each employee, and each employee name appears at the end. And the chain is built from all his or her direct supervisors in a recursive manner. Okay, let's do it, guys. Guys, yeah, not easy. Let's see. So this is a desired format, yeah, as you can see here. And let's start with exactly what we had before. But look, this is a query that we had that generates name manager subordinate pairs, yeah, names, yeah. We'll keep just the names, yeah. You can see that we don't need anything else, but we need this relationship manager subordinate. But in here, we'll just create a view with this one, yeah. Make sure that, okay, you use the proper context here, and for the rest, let's just create or recreate the manager subordinates view. And to look inside to see what it is, yeah, you can use select everything from or the shortcut table, which is specific to Snowflake. Okay. And just like before, you can see we get this. Why I use this? Because right now, yeah, let me close this. Our final query, yeah, let's call it this, yeah, final recursive, recursive query. You see, because this is what we need. This is what we'll use here. We'll have a recursive CTE first. Okay, look for this in Snowflake if you want to know more. Yeah, I describe this also in detail in my other courses. That's an interesting feature, and what you have in a recursive CTE, I'll call it pair. On top, you have two select statements joined by a union or union all. Okay, on top, the first select statement will select the first managers or whatever, and the next query will join, basically will join to the previous query. You can see here in a recursive manner, manager will select the same, yeah, manager subordinates, but I will join basically the what's generated before on, you can see here, manager and subordinate. Okay, so let's have a look. The current manager should be the previous subordinate, should be the one that appears previously as a subordinate. Okay, and for all this, look, I will do this. I will chain manager and subordinates through a dot. Okay, I will do it recursively here because look here, I will collect whatever was generated before and I will append at the end the name of the subordinate. And yeah, you can imagine this goes in a recursive manner for everything. Yeah. So look, I could basically select just this one and execute it, but we're already in a familiar territory from the examples that we looked at before. I will simply issue here an object construct ID with a MS. MS is a pass that I basically constructed here. This is a MS, yeah, the pass. So I will say construct me an object, yeah, for each individual values that I have here with ID and MS, yeah. And then, just like before, I will call array aggregate just to have one single top array, yeah, because this is a desired format with all these objects. Okay, no big deal, yeah. Let's run it, yeah. I executed this one, yeah. I executed this one. Let's run this one. Okay, and if you look on the right side here, yeah, this is what we have, guys. Yeah, the desired format with everything in a top level JSON array.